Not just a circle in the sky. This is the ancient fire of creation. Born from a collapsing cloud, gravity squeezed gas until fusion lit a new star. In its core, hydrogen becomes helium. Light and heat pour across space, sustaining worlds. Sunlight powers photosynthesis, feeds food webs, shapes climates, setting the rhythm of every heart. Our existence depends on its steady glow. The sun, our star, our story. Stay curious, look up. Energy doesn't start in your coffee, it starts in a star. In the sun's core, hydrogen fuses into helium. Mass turns into pure light. That light powers life here. Without the core, Earth turns silent, cold, lifeless. Meet Core Energy Booster. Plant-based antioxidants that support vitality and enhance focus. With 0 artificial additives. Carry sunny focus anywhere. Natural energy made simple. Tap to learn more.
4.5 billion years ago, a silent cloud of dust drifted through our galaxy. Gravity pulled it inward, squeezing atoms tight. A glowing heart began to form. Heat soared until nuclear fire ignited, the birth of our sun. Leftover dust and debris coalesced into planets. One of them became Earth. The young sun's fierce light-shaped orbits, winds, temperatures, beginning the world we call home.
Deep within the sun's core, nuclear fusion creates newborn light that begins its journey through the dense plasma of the radiative zone. Above the radiative zone, the convective zone churns like boiling water as hot material rises and cooler material sinks in a constant dance. When this light reaches the photosphere, it becomes the warm, golden glow we see as sunlight every day. Beyond the photosphere lie the chromosphere and the shimmering corona, forming the sun's magnificent outer atmosphere. Together, these layers shape the energy, heat, and magnetic activity that fill our entire solar system with life-giving power.
Every moment, the sun releases unimaginable amounts of energy, lighting our sky and warming our Earth. This light powers our forests, our oceans, and every breath of life on our planet. When sunlight touches leaves, plants create food and oxygen for all living things. When sunlight warms our oceans, winds rise, waves travel, and weather begins to dance across our world. If the sun stopped shining even for a short time, Earth would freeze in silent darkness. All motion, all life, and all color depend on the sun's constant flow of energy. That's why we're harnessing this incredible power with innovative solar technology to sustain life for generations to come.
Notice dark freckles on the sun? Those are sunspots, clues to our star's mood. They look dark because twisted magnetic fields choke off rising heat, making patches thousands of degrees cooler. Some sunspots dwarf Earth and travel in groups like storm packs. More sunspots usually mean a more active, less predictable sun, part of the roughly 11-year solar cycle. Why it matters? Sunspots signal solar storms and radiation that can disrupt satellites, radio, power grids, and even influence climate. Scientists monitor them to forecast space weather.
Deep within the sun's turbulent atmosphere, a powerful force is building. Magnetic field lines stretch and twist, storing incredible energy. When these lines snap, a solar flare erupts with explosive force. Intense waves of energy race through space at nearly the speed of light. Our atmosphere protects us, but modern technology remains vulnerable. Radio signals, satellites, and critical instruments face disruption. Astronauts and spacecraft must remain vigilant in this harsh environment. By studying these events, we predict space weather and protect our technology future.
The sun, our closest star, holds incredible power. Sometimes it unleashes massive storms into space. These are coronal mass ejections. Billions of tons of charged particles hurtle through space at millions of kilometers per hour. When these storms reach Earth, they interact with our planet's magnetic field in spectacular ways. The result? breathtaking auroras that paint our polar skies with stunning colors. But these storms aren't just beautiful. They can be dangerous too. Powerful CMEs can damage satellites, disrupt communication systems, and even cause widespread blackouts. In 1859, the Carrington event caused telegraph systems to fail, and auroras were seen as far south as the Caribbean. Today, space agencies monitor these eruptions 24/7 to protect astronauts and warn industries about incoming storms. These solar storms remind us how deeply connected Earth is to the sun's ever-changing moods.
Beyond visible light, the sun sends a steady stream of charged particles called the solar wind. This wind shapes Earth's magnetic field, stretching it like a long tail. When the solar wind strengthens, it can disturb satellites and navigation systems. Yet, it also creates magical lights near the poles, painting the sky with colors. The solar wind is a constant invisible force, proving the sun's influence reaches far beyond its glowing surface.
Earth orbits the sun at the perfect distance where water can remain liquid and life can grow. The sun controls seasons, climates, and weather cycles that shape our world. Its warmth keeps our oceans alive with diverse ecosystems. Its light fuels plants that feed every living creature on Earth. Even small changes in sunlight over time can shift temperatures dramatically. We survive because the sun maintains a delicate balance that makes our world possible. If Earth moved slightly closer, we'd burn. Slightly farther, beneath the sun's fiery surface, swirling plasma generates a powerful magnetic field that twists and stretches over time. This magnetic power creates sunspots, flares, and storms that shape the sun's activity. Every 11 years, the sun's magnetic poles reverse, creating a cycle of rising and falling activity. Understanding this cycle helps us forecast solar storms, protecting satellites and astronauts in space. The sun's magnetic field reaches far into space, shaping the behavior of planets, comets, and our entire solar environment.
Though the sun feels eternal, it is slowly using its fuel. Billions of years from now, it will expand into a red giant, swallowing nearby planets in its path. After shedding its outer layers, it will shrink into a white dwarf, leaving behind a glowing shell of cosmic beauty. But this distant future is far beyond human lifetimes. For now, the sun remains stable with enough hydrogen to shine for billions more years. Studying its future helps scientists understand the evolution of stars across our galaxy.
We're flying closer to the sun than ever, on purpose. Here's why it matters. Parker Solar Probe samples solar wind and magnetic fields inside the corona at record speeds. Ground and space telescopes reveal turbulent patterns shaping flares and coronal mass ejections. This data helps shield satellites, power grids, and future Moon and Mars crews. By decoding our sun, we learn how stars live and sculpt planetary systems everywhere.
No sun, no life. Then, golden light ignites Earth. Plants turn sunlight into food, animals thrive, humans depend on them both. Sunlight sets our body clock, shaping sleep, energy, and mood. Ancient cultures honored the sun. Modern science confirms its power to sustain Earth. Solar power is clean and abundant. Without the sun, we collapse. Every moment carries its golden signature.
No sun, no seasons, no warmth, no breath. Then, light arrives and life awakens. A star, yes, but also Earth's guardian, timekeeper, and energy engine. Sunlight fuels photosynthesis, filling our atmosphere with oxygen, every breath a solar gift. It steers seasons, shapes climate, drives winds and currents, balancing delicate ecosystems we depend on. As long as the sun shines, life continues. Our constant companion, the brilliant heart of home.